Welcome you all. In this lecture, I will explain about how to solve some numericals on centrifugal pumps. So now, see this numerical. A centrifugal pump lifts water under a static head of 36 meter of water, of which 4 meter is suction lift. Suction and delivery pipes have both 150 mm in diameter. The head loss in suction pipe is 1.8 meter and 7 meter in delivery pipe. The impeller is 380 mm in diameter and 25 mm width at mouth and revolves at 1200 rpm. Its exit blade angle is 35°. If the manometric efficiency of the pump is 82%, find the discharge and pressure at the suction and delivery branches of the pump. So now, by reading this numerical, list out the given data. First, the centrifugal pump lifts water under a static head of 36 meter. So now the total head is given as 36 meter. The total head is measured from the level of the water in the lower sump to the level of the water in a overhead tank. So that is called as a static head. So that head is now 36 meter. So in which the 4 meter is suction lift. Now suction head is given as 4 meter. That means now distance is measured from the axis of the centrifugal pump impeller to the level of the water on the lower sump is 4 meter. The suction and delivery pipes diameter is given as 150 millimeter. So now the some head loss is there in a suction pipe as well as in a delivery pipe. The head loss in suction pipe is 1.8 meter and head loss in delivery pipe is 7 meter. Now, impeller diameter is 380 millimeter and the width of the impeller is given as 25 millimeter. So now this centrifugal pump revolving at the speed of 1200 rpm, n is given as 1200 rpm. The exit blade angle, that is a beta 2 angle, is 35° and manometric efficiency is given as 82%. So now by this given data, initially find out find the discharge and what is the pressure in suction pipe as well as in delivery pipe. Now these are the given data here. The total static head is given by H is equals to 36 meter and suction head is given as 4 meter. So what about the delivery head here? So now total head is 36 meter. So in that the 4 meter is a suction head and remaining one is now discharge head. The total head is 36. So in that 4 meter of our suction head, that means now delivery head H of D is equals to 32 meter. The diameter of the impeller at exit is 0.38 meter and width of the impeller is given as 0.025 meter. The speed n is equals to 1200 rpm. Then head loss due to friction at the delivery pipe is 7 meter. That is H of FD is equals to 7 meter and HFS at suction pipe is 1.8 meter. So now diameter of the suction pipe is equals to diameter of the delivery pipe is equals to 0.15 meter. The blade angle at exit is beta 2 is equals to 35° and manometric efficiency is 0.82. So now find out what is the discharge Q and pressure at suction pipe P of S and pressure at the delivery pipe of the centrifugal pump, that is a P of D. So this is a velocity triangle for the centrifugal pump at inlet as well as exit. So now manometric head. The manometric head is calculated by the expression, that is a manometric head h of m is equals to static head plus the head loss due to friction in suction pipe as well as a head loss in friction in delivery pipe, that is h plus h of fs plus h of fd. So now HM is equals to the static head is given as 36. The head loss at the delivery pipe is 7 meter and head loss at the suction pipe is 1.8 for that reason. Now total the manometric head is equals to 44.8 meter. So U2 is equals to pi D2N by 60. Now U2 is equals to pi. The outer diameter is given here and the speed is given as 1200 rpm divided by 60. Now U2 is equals to 23.9 meter per second. The manometric efficiency is calculated by using expression h of m manometric head to the VU2 into U2 by G. The manometric head is 44.8. Manometric efficiency is 0.82. So now VU2 is unknown and that is calculated by simplifying this expression and finally getting the VU2 value is 22.43 meter per second. So from outlet velocity triangle, by using the trigonometric relations, that is tan beta 2 is equals to Vf2 by u2 minus Vu2. So now beta 2 angle is given as a 35 degree. Vf2 flow velocity at outlet is unknown Vf2. Then u2 is equals to 23.9 and Vu2 is equals to 22.43. Hence Vf2 is equals to 1.05 meter per second. So now discharge, the Q is equals to pi d2 b2 vf2, that is equals to area of the flow into velocity of flow. So now Q is equals to the area of the flow is calculated by using the expressions pi d2 b2. So here diameter is 0.38 and width of the impeller is 0.025 and velocity of the flow is 1.05. Hence the discharge through the impeller is 0.0314 meter cube per second. Next, what is the velocity at the discharge pipe? The V of D represents velocity at the discharge pipe. So once again this one is calculated by using the expressions. The discharge is equals to area into velocity. So here velocity of the pipe means, that is by considering the area of the pipe. So now the small letter a of D is equals to area of the pipe at discharge and V of D is equals to velocity of the fluid or water at discharge pipe. The Q is equals to discharge at delivery pipe. Now discharge is equals to 0.0314 and area is calculated by using the expressions pi d square by 4. So here diameter of the pipe is 0.15 meter, hence that is 0.15 square and the velocity at the pipe is equals to 1.78 meter per second. Next, velocity head at suction is equals to velocity at discharge pipe, that is equals to 1.78 square by 2 into 9.81. Now that is equals to 0.161 meter. There is a velocity at suction pipe as well as delivery pipe is equals to 0.161 meter. Next, effective pressure head at delivery side. What is the effective pressure at delivery side? Now effective pressure head at delivery side is equals to the H of D is equals to HD. The delivery head plus head loss due to friction in delivery pipe plus the velocity head at delivery pipe. There is a V of D square by 2G. So substituting the values here, the H of D is equals to HD is equals to the delivery head is equals to 32 meter. Head loss due to friction in delivery pipe is 7 meter and velocity head is taken as at a delivery pipe is 0.161. Hence now effective pressure head at delivery side is equals to 39.16 meter. Pressure at delivery side. The pressure at delivery side, the P of D is calculated as the effective pressure at the delivery side plus the specific weight of the fluid, that is a W, small letter W. So that is equals to rho into G. That is the density into gravity. So that is equals to the P of D. There is a pressure at delivery side is equals to the effective pressure at is equals to 39.16. The density of the water is 1000 and acceleration due to gravity, this G value is equals to 9.81, and the pressure at delivery pipe is equals to 384.25 kilo Pascal, that is equals to 3.84 bar. So this is the pressure at the delivery pipe. In similar manner, we calculate the pressure at the suction pipe. Now effective pressure at that suction side, so that is H of S is equals to this suction head plus head loss due to friction in suction pipe plus velocity head at suction pipe, that is V of S square by 2G. H of S is equals to the head at the suction head is equals to 4 meter. Head loss due to friction in the suction pipe is 1.8 meter and velocity head is equals to 0.161, that is equals to 5.966 meter. Pressure at suction side, that is the P of S is equals to H of S plus specific weight, that is P of S is equals to 5.96 into density rho is equals to 1000 into G is equals to 9.81, and the pressure at suction side, suction pipe is equals to 58.5 kilopascal, that is equals to 0.585 bar. So this is a solution for the centrifugal pump. The next numerical on a centrifugal pump. A centrifugal pump having outer diameter equal to 2 times inner diameter and running at 1200 rpm works against a total head of 75 meter. The velocity of flow through the impeller is constant and equal to 3 meter per second. The vanes are set back at an angle of 30 degree at outlet. If the outer diameter of impeller is 60 cm, the width at outlet is 5 cm. Determine first one vane angle at inlet, work done. Third one is manometric efficiency. Say here the centrifugal pump having outer diameter equals to 2 times of inner diameter. That means the D2 is equals to 2 times of the D1. That is inner diameter, and speed is equals to N is equals to 1200 rpm. So that again works against head of the manometric head is equals to H, M is equals to 75 meter. The velocity of the flow through the impeller is constant and equals to 3 meter per second. That means Vf1 is equals to Vf2 is equals to 3 meter per second. The velocity of the flow is constant from the inlet to the exit. The vanes are set back at an angle of 30 degree at outlet. That means beta 2 angle is 30 degree. If the outer diameter of impeller is 60 centimeter, the outer diameter of impeller is given, that is 60 centimeter, that is the D2 is given, and width at the outlet is also given as the B2 is equals to 5 centimeter. So now we have to calculate what is the vane angle at inlet, that is what is the beta 1, what is the work done, and what is the manometric efficiency of the centrifugal pump. So now list out the given data here, that is a D2 is equals to 2 times of D1, N is equals to 1200 rpm, manometric head is equals to 75 meter. Now VR1, the Vf1 is equals to Vf2 is equals to 3 meter per second, beta 2 is equals to 30 degree, D1 is equals to 0.6 meter, B1 is equals to 0.05 meter, beta 1 you have to calculate, and what is the work done and what is the manometric efficiency. So now draw the velocity diagram for this centrifugal pump, that is a radial inlet, that for that reason that is a right angle triangle at inlet, then for that reason V1 is equals to VF1, that means alpha 1 is equals to 90 degree. So this is the velocity triangle at inlet as well as outlet of the centrifugal pump. So now U1 is equals to pi D1 into N by 60. The diameter D1 is given is 0.6 and 1200 divided by 60 is U1 is equals to 37.69 meter per second and U2 is equals to pi d2 n by 60. U2 is equals to 75.39 meter per second. So now inlet vane angle. The inlet vane angle is calculated by the relations the tan beta 2 is equals to Vf1 by u1. So tan beta 1 is equals to the flow velocity is 3 meter per second. There is 3 by u1 value is 37.69. So now beta 1 angle is blade angle, vane angle at inlet is equals to 4.55 degree. Now what about the work done per second? So now here the tan beta 2 is equals to Vf2 by u2 minus Vu2. So here tan beta 2 angle is given. There is a beta 2 angle is given as 30 degree and velocity of the flow is 3 meter per second and u2 value is equals to 75.39 minus Vu2. So here Vu2 is unknown and that Vu2 value is calculated as 70.15 meter per second. By using the discharge formula, the discharge is equals to area of the flow into velocity of the flow. The area of the flow is equals to pi into d1 into v1. So now pi into 0.6 d1 and width of the impeller that is 0.05 into 3. Now discharge is equals to 0.283 meter cube per second. So now what is the power or work done by the pump? So that is a P is equals to rho into Q Vu2 into U2 by 1000. So here density of the water is 1000 and discharge is 0.283 and Vu2 value is 70.15 and U2 value is equals to 75.39 divided by 1000. So that means the work done per work done here 1495.32 Newton meter. Now what about the manometric efficiency? The manometric efficiency is calculated by using the expression manometric efficiency is equals to GH by U2 VU2. So that is equals to 0.9 and head here G value is 9.81, head is equals to 75, U2 value is equals to 70.15 into U2 value is equals to 75.39 and the efficiency is equals to manometric efficiency is equals to 13.9%. So take down next numerical on a centrifugal pump. A centrifugal pump running at 1000 rpm. The outlet angle of vane is 45 degree and the velocity of the flow at outlet is 2.5 meter per second. The discharge through the pump is 200 liters per second when the pump is working against the total head of 20 meter. If the manometric efficiency of the pump is 80%, it determine diameter of the impeller, width of the impeller at outlet. So now see the given data here. So now centrifugal pump working running at the speed of 1000 rpm, n is equals to 1000 rpm. The outlet angle of vane is 45 degree, beta 2 is equals to 45 degree and the velocity of the flow at outlet that is V of 2 is equals to 2.5 meter per second. The discharge through the pump there is a Q is equals to 200 liters per second. So convert that into meter cube per second by multiplying with that 10 to the power minus 3. When the pump is working against a total head of 20 meter, there is a manometric head is given as a 20 meter. If the manometric efficiency pump is given as 80%, now determine what is the diameter of the impeller as well as the width of the impeller. That is D2 as well as B2 at outlet. So this is the corresponding velocity diagram for centrifugal pump at inlet as well as exit. So now diameter of the impeller. So from outlet velocity triangle, the tan beta 2 is equals to Vf2 by u2 minus Vu2. Here the beta 2 angle is 45 degree. The velocity of the flow is 2.5 meter. Then so there are two unknowns u2 and Vu2. These are the two unknowns now. So now Vu2 is equals to u2 minus 2.5. So that is taken as equation number 1. So we know that the manometric efficiency is equals to GH by U2 into VU2, or manometric efficiency is equals to 0.8, that is equals to 9.81 into 20 by U2 VU2, that is expression number 2. So comparing the 1 and 2, comparing these two expressions. So now U2 minus 2.5 is equals to 245.25 by U2. So now we are getting the value of U2 is calculated by this one by expression. This is U2 square minus 2.5 U2 minus 245.25 is equals to 0. So now by using the quadratic equation, that is U2 is equals to minus B, that is a minus into minus. Here the A value is equals to 1, the B value is equals to minus 2.5 and C value is equals to minus 245.25. And this expression becomes, that is a minus B plus or minus square root of B square minus 4AC. See here, for that reason, that is a minus into minus of 2.5 plus or minus the square root of B square. The B square is equals to minus 2.5 square minus 4 into A value is 1 into C value is equals to minus 245.25 divided by 2 into A. The A value is equals to 1, hence the U2 is equals to 16.96 meter per second. So now the U2 is equals to pi d2n by 60. The U2 value is known, that is 16.96. So now d2 is calculated and that value is d2 is equals to 0.324 meter. So now width of the impeller at outlet. The width of the impeller at outlet is calculated by using the discharge formula. The discharge is equals to area of the flow into velocity of the flow. The area of flow is equals to pi d2 b2 and velocity of the flow is equals to vf2. Hence pi into 0.324 into the width is unknown into velocity of the flow is 2.5. Hence the B2 is equals to, or the width of the impeller at the outlet is equals to 0.078 meter. So these are the some numericals related to the centrifugal pump. Thank you.